Hello, in this video for Mathematics High Level, I'm going to go through what happens when I try to solve quadratics that have complex number solutions. You should have a bit of an idea of how complex numbers work, and particularly know a little bit about complex conjugates. So let's take a look at it. So suppose we try to solve here this quadratic here, right? X squared plus x plus 1. Well, if you go straight into your quadratic equation, which I hope you're familiar with, you're going to get the following thing. You're going to get to complex numbers here is the solution, because you end up with square root of minus 3, so that's square root of 3 times I, and hence you have these two solutions. I could write it separated in two different fractions, and hence the real part of this solution would be minus 1/2, and the imaginary part of this solution would be square root of 3 divided by 2. So realize the following thing that happens here. The solutions to this quadratic are complex conjugates. Right? You see, the only thing that changes from here to here is the sign. So complex conjugates are the solutions to this quadratic. Is this something that's always going to happen? No, it's a rule. Solutions of real polynomials come in conjugate pairs. Keep that in mind, that's very important. Happens. So if I have this complex polynomials, if I have this quadratic here and I solve it, I'm going to end up with the following two solutions. Again, complex conjugates. 1 plus 2i is one solution of these quadratic equation, and 1 minus 2i is the other solution. So in the same way that I can write this quadratic that is nicely has two nice real roots, in the same way that I can write this quadratic in the factorized form, I'm going to be able to do the same thing with this one. I'm going to be able to write it like this. Now, she's like, why would you ever want to do that? It's going to have its advantages. But actually, if you open this up and you multiply it, you are going to get this polynomial. Which is kind of neat. Now, because they're conjugates, there's going to be some consequences this has. Solutions come in complex conjugates. I will be able to figure out some things here and there. So if you get this polynomial, it's in reverse, right? And you actually open it up, right? This is what's going to happen. You're going to end up with x squared minus x times 2 plus I, and so on. Now, it's going to take a lot of calculations, but you end up with this, and then further on, this xi's cancel, and the 2i's cancel. Now, if you think about it, that's always going to happen. That's always going to happen, whether you have here 2 minus I, or you have here 4 plus 2i. These parts here are always going to cancel out. And hence you're always going to end up with the same thing. And what's going to happen is that realize that this is minus 4 here. This is always going to be minus 2 times the real part of your complex number. So you can take the 2, to multiply times 2, and you make negative, and that's what's going to be here. Whereas this part here is always going to be the modulus of the complex number squared. The modulus of this complex number is square root of 5. You square it, you get 5. And that's going to be a rule, because these parts are always going to cancel each other out, no matter what complex number I have here. This might save us time later on in the game. So we come to like a fundamental theorem. Suppose that you have, the idea is that any polynomial, the degree that it has exactly n roots. Now, sometimes the roots can be repeated. This is going to be kind of complicated. Why bring this up? So this is the fundamental theorem of algebra, and the idea is that, the previous one we had, x squared plus x plus 1, that had 2 roots. Now, 2 of them were complex, but that means it still has 2 roots. So any polynomial of degree n is going to have exactly n roots. It's very important to know. And this one here is the fundamental theorem of algebra. Now, you might think, well, not so quickly, because x squared equals 1 only has one solution, x equals 1. Again, this might not be the case. It actually has 3 solutions. Here they are. And I recommend you try it. Try to put this in here, and you see it's going to give you 1. So the way in which we find all the roots of a polynomial are going to be explained in the next presentation. But you have to keep in mind that if you have a polynomial to the power of 3, it's going to have 3 roots. Now here's an invitation of what's going to come. Suppose we'll try to solve this thing here. We'll find the solutions, -3 and 1, and I can plot them in the real line. And here they are. Nothing extraordinary about this. I've seen this before. What happens if I plot the solutions of x cubed equals 1? The three solutions that I said it has. And I plot it in an organogram diagram because I can't plot them in the real line since they're not real numbers. This is what it's going to look like. And of course, you can see there's a bit of a geometric shape hiding here. It's an equilateral triangle. And this is what's going to happen. You're going to get all these wonderful geometric shapes the moment that you start plotting your solutions to the polynomial in an organogram diagram. And that's something that I think is kind of interesting and neat. Anyway, thank you very much for watching. I'll see you next time. Goodbye.